Assalamu alaikum, students. Today, this is the third uh, video which I am going to prepare for you for the revision of mechanics. In this video, I will try to finish from question number 3 till question number 12. All questions are related to forces and equilibrium. So let's look at the question number 3, in which he says two forces have magnitude P Newton and Q Newtons. So there are two forces given, Q Newton force and P Newton force, and both forces are making 120-degree with each other. You remember in video number 2, I told you that if examiner gives you two forces, P force and Q force, and he gives you the angle between them, you can easily find the resultant. The magnitude of the resultant is P squared plus Q squared plus 2PQ cosine of the angle between the two forces. And if the resultant is making an angle alpha with the force P, you can find this alpha. Alpha is equals to inverse of sine. Use the opposite force Q. If you want to find this alpha angle, which is between R and P, you have to write here Q, then times sine of the angle between the two forces, which is theta, divided by the resultant. So you must have the value of the value of R before finding the angle alpha, which resultant makes with the force P. In the same way, you can find an angle beta, for example, which the resultant is making with Q. So beta will be equals to inverse of the sine. Now we will use P. P times same thing here, sine theta over magnitude of R. So these were the things which we did it or revised in video number 2. Now let's try to solve this question. Um, the angle between the two forces is 120 degrees. I want to tell you one thing very important in 9709. When the examiner shows resultant also in the diagram, he will show it not by solid line, he will show it by dotted line, so that the students will not be confused during the exam and they will consider that this is a third component force. No, 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 no. So, or maybe you guys can read the statement: the resultant of the two forces has magnitude 12 newtons. So if you remove both forces, you will find the body is moving in this direction, because this is the resultant and the magnitude of the resultant is 12 newton, and it is making 80 degrees with Q and 40 degrees with P. So let's start the question. What is required? The required thing is Q. We want to find what is Q force. Um, I I can also ask you in the exam, for example, what is the P force? So both forces can be found out. So let's try to find Q force. So if I want to find Q force, I have a 12 Newton force and the angle between them is 80 degrees. So I will use the sine rule formula. 80 degrees, the angle between the force and the resultant, is equals to inverse sine. What is the opposite force? This is P Newton force times sine of the angle between the two forces, 120, divided by the magnitude of the force. It is already given to you, that is 12. Now you will ask me this question: the only unknown seen in this expression is P. Are we finding P? The answer is no, we are not finding P. We are finding Q. So let's use the other formula. What is the other formula I can use? Now, the resultant is making 40 degrees with P. So I'm going to write 40 degrees is equals to inverse sine, okay, which force is opposite to P, yani other than P, component force given to you, Q. So I'm going to write here Q times sine of 120 divided by 12. Now I can use calculator directly to find this Q force. How? I can write 40 equal sign and then inverse sine. Make sure your calculator in a degree mod, then write a fraction. In the place of Q, because Q is unknown, I will write X times sine of 120, close the bracket, bring the cursor down in the denominator, write 12, and now close the bracket. So once you confirm that you copied the whole equation into the calculator display, now the time has come to solve the equation. Press shift and then solve. Calculator will take an initial guess, just ignore it and get your answer. So you got 8.91. So Q is equals to 8.91. Now examiner has given 4 marks. If the examiner has given 4 marks, definitely he will require from you some steps. Um, Yani here he doesn't want the student use the equation solver directly. I wrote it just for the sake of no error and saving time happens to us. So this is 3 significant figures. However, if a student wants to show full steps, he can do it like this. Send the shift sign to the other side, it becomes sine of 40 degrees. It is equals to Q times sine of 120 degrees over 12. So send everything to the other side. So 12 is here in the denominator. It will go to the numerator on the other side. So 12 times sine of 40 degrees and then divided by, this was multiplying, it will go in the denominator. So sine of 120 degree is equals to Q. Clear? So let's try to find this answer. It must be the same as what we have already calculated by using equation solver from the calculator already. Sine of 120. Guys, can you check that? The answer which we got, that was 8.91. So if in the exam he asks you find Q, you calculate it. If he asks you to find P, I can also calculate it, but it was not required. I can, use the same procedure to find the value of P. So no need to do this step here. So look at that. The steps which I have shown over here, they are worthy of 4 marks. Now let's go to the question number 4. In question number 4, I can see the diagram. He has given 7 Newton force, he has given 5 Newton force, and 6 Newton force. This force 7 Newton is already acting along x-axis. So it means no need to resolve this force along x-axis and y-axis because it is already along x-axis. But the force 5 Newton, it is not along x-axis or y-axis, it is making some angle with the x-axis, so it has to be resolved, and the 6 Newton force has to be resolved. So let's do the resolving. The x component of 5 Newton is, look at that, I'm showing it, 5 cosine of 50 degrees, and the x component of 6 Newton is 6 cosine of 30 degrees. So how many x components I found? 7 Newton force, 5 cosine 50, and 6 cosine of 30. It tells you like There is a body, two forces are acting on the right hand side and one force is acting on the left hand side. Yani this is 7 Newton force and this is 5 cosine of 50, and here 6 cosine of 30 degrees. I want to find what is the net effect on the body. So definitely you will find the x net. You will add these two forces. You'll write in the bracket 7 plus 5 cosine of 50 degrees, then minus the force which is on the left hand side, 6 cosine of 30 degrees. Let's use calculator. 7 plus 5 cosine of 50, close the bracket, again close the bracket, minus bracket open, 6 cosine 30, close the bracket, again close the bracket, and get your answer 5.017. I'm writing this answer from the calculator to four significant figures because maybe I will use this answer when I will be willing to find the magnitude of the resultant. So 5.018, 5.018 for SF. Okay, let's look at our y components. This force 7 Newton has no y component because it is not acting along y axis. However, 5 Newton force, this is the y component, so I will write it as 5 sine of 50 degrees, and this force which is 6 sine of 30 degrees. So there are two components. One force is acting upward and the other one is downward. Let me explain you. If there is a body, there is one force acting upward and one force is acting downward. What is that force which is acting upward? This is 5 sine 50 and this is 6 sine 30. So to get the y net, the net effect vertical is, we always do upward force minus the downward force. So 5 sine 50 minus 6 sine 30. Now let's use the calculator. 5 sine 50, close the bracket, minus 6 sine 30, close the bracket, and get your answer 0.8302. 0.8302 to the 4 significant figure. Now the points to be noted here. Our x net is positive, our y net is positive. What this thing tells you? This thing tells you that this whole system is converted into this situation. There is an x net because it is positive. What is the magnitude? 5.018. There is a y net which is positive. It means it is acting vertically upward. What is the magnitude? 0.8302. Wow. I can use Pythagorean to find the resultant. So look, the resultant is acting in this direction, and I can also find the direction of the resultant by using trigonometry. So come on, tell me, what is my resultant? My resultant is equals to, normally we call it as x net square plus y net square. So resultant is equal to a big square root 5.018, put a square on top, and then 0.8302 whole squared. Write this thing in a calculator. Plus, and we got 5.09. Now I can write it to the three significant figures because this is my final answer. I'm not going to use it anywhere. This is done. Now I also want to find alpha because the examiner is asking you to give the direction of the resultant. So resultant, which trigonometric ratios is suitable here? Obviously, you will say that this is opposite and this is adjacent, TOA. So tan of alpha is equals to, which is this is the opposite, 0.8302 over 5.018. You remember what was this? This was y net, and that was what? X net. That's why I always tell you the formula to find the direction of the resultant is alpha is equals to inverse tan of y net over x net. Anyways, send the tan to the other side, and now you got alpha is equals to inverse tan 0.8302 over 5.018. Use the calculator now. Inverse tan fraction 0.8302 over 5.018. Close the bracket and get your answer. 9.39, 9.4, guys, because angle in A levels or IGCSE has to be given to the one decimal place. So 9.4 to the one decimal place, we got this answer. Okay. If in the exam you just write 9.4, examiner will not give you the accuracy marks. You have to give reference. So as you remember, in this direction, which force was acting? This was 7 Newton force. So 7 Newton force. So I will say that the resultant will make 9.4 degrees anti-clockwise. So resultant will make 9.4 degrees with 7 Newton force anti-clockwise. Clear? Let me show you the marking scheme as well. In the marking scheme, which question we did it? Let me go back to question number 4. We did it, huh? Okay. In question number 4, how the examiner will give you the marks for that? He's gonna give you, he has put total marks 6, right? Did we do question number 4 or question number 3? I think, yeah, question number 4. I write x net, he writes capital X. So this is x net. He gave you 1 accuracy marks. Writing the y net, he gave you A1 follow through marks. M1 is finding the components. If the student has found the components correct, then he will give you the method marks. Then using the Pythagorean formula, this is the method marks. Tan theta, which we use it, guys, you saw that, method marks. And then if the student has given the magnitude correct and the direction is also correct, then you will get, look, the reference of 7 Newton is also provided. So anyways, this was the marking scheme, standard marking scheme. Our answer is matching with the marking scheme. I don't think so, students, you will have any problem. You can easily resolve the forces, and then you know that how to find the magnitude of the resultant and the direction of the resultant. Now, in this question, again, you can see there is a dotted force. It means this is not the force which is a component force. Basically, in this question he has given you three forces: 20 newton force, F newton force, and 10 newton force. The dotted force is the resultant of these three forces. Clear? So how to solve this question? I will definitely look at the components of every force. No need to resolve 20 newton force because it is already acting along x-axis, so no need to resolve it. I will try to resolve first of all our F newton force. So the x component of F newton force will be, come on, F cosine of 70. So this is done. And the x component of 10 newton force will be 10 cosine of 30 degrees. This is done. So let's try to write our x net. I'm going to write it here, x net. In the marking scheme he write capital X. Okay, so uh, it looks like on the body there are two forces acting on the right hand side and one force acting on the left hand side. What are the two forces acting on the right hand side? These are the two forces. So let me write them in a bracket: 20 plus F cosine of 70, then minus, so these two forces, minus this force, which is 10 cosine of 30. Clear? So two forces on the right and one force on the left. We found the net x effect of the resultant. We found it. Now I will bring your attention to very, very important thing. In the previous part, the resultant was not given, was not shown to you, right? And in this case, he gave you the resultant. Why and how can we use it? Lovely. Since the resultant is given, yani resultant is mentioned to you and it is acting in this direction, it tells you very important thing, and that thing is, if the resultant is acting in this direction, means the x net is positive and y net is downward, because the guy has shown resultant here. So x net is positive. Positive means whatever we will get from here, it will give us a positive answer. Okay. Anyways, now y net, I know you guys will say, Mr. Upward forces minus downward forces. No, since the resultant, yani y net, is acting downward, it means downward forces are positive, yani the body is going downward, so downward forces are positive minus the upward forces we have to use, because in this case the resultant is given. If the resultant was not given, that was a general rule that upward forces minus downward forces. But now I can locate the direction of r, that the net effect is downward. If the net effect is downward, it means downward forces are more. The sum of the downward forces is more than the sum of upward forces. Let's try to resolve the upward and downward forces. Now I will use a different color. So this force, which is F sine of 70, it is acting vertically upward. And this force, which is 10 sine 30 degree, which is acting vertically downward. Don't try to take the resultant's force among these forces. For y net, I need to write it. It should be R sine of 15, and the x net for the resultant is R cosine of 15. Let me write it here. It should be equals to R cosine of 15. Agreed, guys? I'm talking about x net. Resultant is given, so right hand force will be R cosine 15, and downward the y net will be R sine 15. Now I'm going to write the y net. Again, I will repeat, don't take this one positive because the net effect is downward. So I will write this force first, 10 sine 20 minus the upward force, which is F sine 70. It is equals to, what is the uh, net y net for the resultant given in the question? That is R sine 15. Wow. Now I got two equations. I got two equations. And these two equations have two unknowns, same unknowns. What are the two same unknowns? F, R. F, R. This thing revealed to me a very important concept in algebra. We took it, that is called simultaneous equation, the linear system of linear equations in two variables, and we call them simultaneous equations. Can I write the two linear equations? 2x plus 3y is equal to 7, 5x plus 8y is equal to 9. You remember that this is the linear equation, this is the linear equation in two variables, x, x, y, y. It looks like the same situation, but we need to organize both equations. How I do this organization? I will keep 20 and minus 10 cosine of 30 degree on the left, and send f cosine 70 to the other side. So R cosine 15 minus f cosine of 70. And also I will keep it here and send this to the other side. So I'm going to write 10 sine 20 equals R sine 15 plus f sine 70. Now I would suggest you to simplify this expression from a calculator. What is that? And try to write it to the four significant figures. So 20 minus 10 cosine of 30. What is the answer? We got it 11.34. So this is 11.34. What is cosine 15? Cosine 15, it is equals to 0.9659, 0.9659 along with R. All values I'm writing them to the four significant figures. Now minus cosine 70, I got minus 0.3420, minus 0.3420 along with F. 10 sine 20, 10 sine 20, I got this answer 3.420. 3.420. I'm talking about this. So this is simplified to the four significant figures like that. Now sine 15, I got this answer 0.2588. 0.2588 R. I'm talking about this. So this is simplified to this form. Now sine 70, I got 0.399397. 9397F. Right, guys? I have simplified this. After doing this, I got system of two simultaneous equations, and from the calculator I know how to solve it. How? Go to the menu, search for equation mod, then simultaneous equations. One, two variables I'm dealing with, two. Now, to be more accurate in the final exam, guys, I need to use the exact answers. So what is the coefficient of r I have? Cosine of 15. I'm going to write cosine of 15, close the bracket, enter. Now this was the coefficient of r. Can you confirm I wrote it 0.9659? Then negative cosine of 70, close the bracket and get your answer. Did I write this already? Minus 0.342. Now on the other side I have 20 minus 10 cosine of 30, close the bracket. Did I already write 11.34 to the four significant figures? Now copy the coefficient of r now, sine of 15, close the bracket. It became 0.2588. Now the coefficient of f, sine of 70, and then 10 sine of 20. After writing all the values into the calculator, now I'm going to press equal sign. It will give me 11.9, the value of r. The value of r is 11.9 newtons. And the value of f from the calculator, next press equal sign. It will give you 0.37. 0.37. Yes, in the final exam, you can show some steps of solving simultaneous equations, which is pretty simple. You can cancel f and try to get the value for r. Uh, this is well understood. You know how to solve the simultaneous equations manually. I want to check my answers from the marking scheme. 11.9 and 0.37. Let's check. Did we get the same answer? Let's check that. This was our answer, which we got it. Video solutions. We got 11.9 and 0.37. Is our calculator giving us right answers? 20 plus f. I want to check it again. Which question we were solving? We got f 1.9. We got f 1.9. Is it the same thing which I wanted to get? Let me see again. Did I do any mistake or not? 20 minus 10 cosine of 30. 20 plus f, okay, minus, right, 10 sine of 20. Oh, that was 30. Sorry, guys. That was 30. 10 sine of 30 and minus f cosine of 70 is equals to r sine of 15. So 10 sine 30 minus f sine 70. Can I just make this correction? That's why I'm verifying my answers. So no mistake should happen. I copied 20 over there. It was actually 30 degrees. So where is the mistake? So just let me correct it. Okay. Now I'm gonna just write the expressions again. This is okay. First one is okay, second one is okay, third one is okay. The next one is 10 sine 30. This is fine. This is fine. Last one, 10 sine 30. Close the bracket. Okay. We got answer 12.4. No need this one. The value of R comes to us 12.4 newtons, and the value of F is 1.9. Thanks God. This is the final answer, and it is matching with the marking scheme 1.9 and 12.4. How the examiner has set the marks: one mark for the resolving, one accuracy marks for writing the correct equation, second yani horizontal equation, one mark for the vertical equations. Look at that, examiner has put one mark, one method marks for the for showing that the student is trying to solve it by simultaneous equation. So I would suggest you guys in the exam show manually how we can solve this equation. Accuracy is related to with F and R, both is will give you the accuracy marks. Now let's move on to the next question. Question number 6. We can see now we have all four forces. There is no resultant given in this question. We want to find the magnitude and the resultant of the force. This force is already acting along x-axis. This force is already acting along y-axis. So no need to resolve these forces. We just need resolving of this force, 7 newtons. That has to be 7 cosine of 60, and this force is 3 cosine of 30 degrees. So x effect or x net, it is 5 minus, bracket open and close, there are two forces acting on the left hand side, so 7 cosine 60 plus 3 cosine of 30 degrees. So this is the x net. Let me try to calculate it. So 5, go to the computing mode. So 5 minus 7 cosine 60, close the bracket, plus 3 cosine 30, close the bracket, and get your answer. We got it minus 1.098, minus 1.098 to the four significant figures. Now we will also try to get our y net. So y net is going to use a different color. One force is acting vertically upward and two forces are acting vertically downward. No resultant is shown, so it means the upward force by default will be taken positive. So 7 minus 3 plus, not 3, 3 sine of, because this is 7, let me correct it, 7 sine of 60 degree vertically upward, and this one is 3 sine of 30 degrees. So I'm gonna write 7 sine 60 minus 3 sine 30 plus 4 downward. So let's try to calculate it. 7 sine 60, close the bracket, minus 3 sine 30, close the bracket, plus 4, close the bracket. Yes, what is the answer? We got it 0.562. 0.562. Write it to the four significant figures. Yes. Now y is positive, but x is negative. Can I draw a rough diagram? X net backward, y net upward. So what would be the direction of the resultant y's? So this is your resultant. Can I find this alpha? In other words, r is here, and this is your x net, and this is your y net, and this angle is alpha. Can we calculate it? Resultant is easy. A big square root, take the square of this value, 1.098 squared. When you write it under the square, no need to write the minus sign. 0.5622 squared. Now get your answer. 1 square root of 1.098 squared plus 0.5622 squared, and this will give you the square root, oh yes, 1.23. Resultant is 1.23 newtons. Also, I want to find the alpha. Shift tan y net, which is 0.5622. Again, guys, I'm telling you, don't write the negative sign. Just copy their positives. We know the direction of the resultant now very well. It is in the second quadrant. 1.098 and close the bracket. We got the answer 27.1. So this angle is 27.1. So this 27.1. Since there is no force acting in this direction, I need this angle, which my resultant is making with the 5 Newton force. So 180 minus 27.1, it gives me 152.9. It is making anti-clockwise with the 5 Newton force. So let me write here, my alpha is inverse tan y net 0.5622 over 1.098, which gave me 27.1. Now my resultant is making 152.9 degrees with 5 Newton force anti-clockwise. Let us verify our answers from the marking scheme. Guys, did we get the same answer? 1.23 and 152.9 anti-clockwise from the positive x-axis. This is up to you. You can mention 5 Newton force or with the positive x-axis. Examiner will give you the marks for that. So resolving components, method marks, accuracy, if this is 4 significant figures accurate, 0.56 is to accurate, so method marks. And then again method marks if a student has used this thing somewhere, the Pythagorean and the tan thing, and once the accuracy come 1.23 and 152.9, then the student get the accuracy mark. So 6 marks total examiner is giving to you. After finishing with the question number 6, let's move to the question number 7. In question number 7, there are few things, guys. I want to mention it to you. First time I have seen the forces are not making angle with the horizontal, but they are making angle with the vertical. So let me try to explain you when I resolve this force, 6 Newton force. So this force and this force, any force which is against or opposite the angle, that is always with the sign. So I'm going to write this as 6 sine of alpha. This is 6 sine of alpha, and this should be what? 6 cosine of alpha. Agreed? Okay, now as you see, this is alpha, this is 90. How much this angle should be? Because you remember that the total angle is 180. So this angle should be 180 minus 90 minus alpha. When you open the bracket, so it will give you 90 minus alpha. So this angle should be 90 minus alpha, this angle. Can I make a right angle triangle here? Upward force and down. So this is 90 degrees. If this is 90 minus alpha, this is 90. So that has to be alpha. In front of alpha, as we already know that this has to be a sine component, so it is 8 sine of alpha, and this should be 8 cosine of alpha. Clear? Let me erase all these things. Done. So you got the idea that how the forces are resolved. I want you to tell me what is x net now. X net is, we have 7 newtons to the right minus 8 cosine of alpha and plus 6 sine of alpha. He has given you sine of alpha equals to 3 over 5. I can use trigonometry. This is alpha. Sine is so opposite over hypotenuse. This is opposite. This is 3 and this is 5. I can use trigonometry. 5 squared minus 3 squared, which will give you square root of 16. That is 4. An adjacent is found. So I can easily say what is my cosine? 4 over 5. I can easily say what is my tan of alpha, which is 3 over 4. I can find my trigonometric ratios. Since I didn't teach you trigonometry till now, I would suggest you find alpha from here. So alpha is equals to shift sine 3 over 5 and calculate this angle to the two decimal places. Shift sine 3 divided by 5 and it gives you 36.87. So I'm going to write 36.87. Can I plug 36.87 here and get x net? 7 minus bracket open 8 cosine 36.87 close the bracket plus 6 sine 36.87 close the bracket and again close the bracket. Get your answer, negative 3. Wow, so that resultant x effect is towards the left. I need to find my y net now. The y net is upward force, which is 8 sine of alpha, and there is only one downward force, minus 6 cosine of alpha. So can I substitute the values of alpha here, which is 36.87? So 8 sine 36.87 close the bracket minus 6 cosine 36.87 close the bracket, and it gives us a very small value, which is I think approximately I can say it is 0 because they are balancing each other. Let me check it again. uh, 8 sine of alpha 36.87. We got it. Do we have any other force? Because this force is very small. Let me check it again. 8 sine of alpha, which is 36.87 minus 6 cosine 36.87 close the bracket. Yes, it is 0. approximately 0. Okay. Now I want to find my resultant. If the y net is 0, so resultant will be the same as the x net. So resultant's magnitude, I can write it here, any 3 squared plus 0 squared. The answer will be just 3. And resultant is acting in this direction with 3 newtons. This is the opposite direction. Clear? So what should be the direction now? The direction is opposite to 7n. So resultant magnitude 3 newtons acting in the opposite direction of 7 newtons. Look, interesting thing was 0. The y net, because that was very, very small value came to me. So y net was 0. And x net was negative 3. So it was acting in the opposite direction of 7 newtons, which we have mentioned it over here. Let's try to check our answer from the marking scheme. Can you check that? 1 mark the examiner has given for writing the components, yani resolving, then accuracy, y method for accuracy. Did you see that guy has written 0 here? And then finally, we found the resultant is 3 Newton acting to the left. Now we go to our work. So Alhamdulillah, we are done with the question number 7. Now we go to the question number 8. Again, we have 4 forces given. Let's try to resolve them. But the beautiful thing here is system is in equilibrium. Guys, when the system is in equilibrium, it means the resultant is 0, x net is 0, y net is 0. If x net is 0, it means the sum of all the right hand forces should be the sum of the left hand forces. Upward forces, sum of upward forces should be equal to the sum of downward forces. So in the case of equilibrium, we will use these equations instead of finding x net. Okay, so look at the diagram. The x net of 12 Newton is 12 cosine of 75. The x net of 15 Newton is 18 cosine of 65. The x net of p Newton is p cosine of theta. No need to use the x net of 15 because it is acting vertically downward. So it means two forces are acting on the right hand side and one force is acting on the left hand side. Can we make this equation? So 12 cosine 75 plus p cosine of theta should be equals to 18 cosine of 65 degrees. And the sum of the right hand forces is equal to the sum of the left hand forces. So try to make p cosine theta as a subject. So send this term to the other side. 8 cosine of 65 minus 12 cosine of 75. So this equation is found by using the x effect. I'm going to use the y effect. This is the y effect of 12 Newton, which is 12 sine of 75. This is the y effect of 18 Newton, so 18 sine of 65. Uh, we already have 15 Newton acting vertically downward, and this one is the p sine theta effect of p Newton force. So two forces upward, two forces downward. Let me make the equation. 12 sine 75 plus 18 sine 65. The sum of upward forces is equal to 15 plus p sine of theta. Let us try to make p sine theta as a subject by sending it to the left hand side. So I'm gonna get 12 sine 75 plus 18 sine 65 minus 15 is equal to p sine of theta. Let's try to calculate these values. So it will give you what? P cosine of theta is equal to what? And P sine theta is equal to what? Use calculator. 18 cosine 65, close the bracket, minus 12. Don't forget in the exam to close the bracket, otherwise everything which you will write in the calculator comes in the angle of cosine. So be careful, bracket open and bracket close. Only 65 is an angle. So 12 cosine of 75, close the bracket, get your answer 4.501. 4.501. Next, 12 sine 75 plus 18 sine of 65, close the bracket, minus 15, and get your answer 12.90. 12.90. Or you can write 4 also if you want it. So this is my p cosine theta and this is p sine theta. The interesting thing is, guys, this is p sine theta and this is p cosine theta. This is theta and this is p. Do you agree with me? You all agree with me that this right angle triangle is giving you, this is the force P, the x component is P cosine theta, and the y component is P sine theta. Can I apply Pythagorean? So you will all agree with me, Mr. Omar. P cosine of theta whole squared plus P sine of theta whole squared is equal to P. So Alhamdulillah, I can easily find P from here. Take the square of this. So no need to know about the trigonometric identity. You can use the p cosine theta, p sine theta as the component of the force. So square root of 4.501 squared plus 12.904 squared, and I got my answer 13.7. 13.7 newtons, three significant figures. But keep this answer safe and substitute it maybe first equation or the second equation. So I'm gonna substitute it here. This is my answer, right? I'm gonna write answer times cosine of theta, which is x. I want to find it, equals 4.501. Shift solve and get your answer. I got 289. Oh man, this is a reflex angle. I'm finding it. So equation solver is not helping me. Although I can get my answer by changing my guess, I will give my answer, any initial guess 20 degrees. It will give me 89.1. But you can do it manually by writing this equation in this way. And this is 13 point, I think that was 71, something like that, four significant figures. Cosine of theta is equal to 4.501. Then cosine of theta is equal to 4.501 divided by 13.71. And then theta is equal to shift cosine 4.501 over 13.71. So that will give you 89.1. Okay, let me show you the marking scheme. We are done with the question number 8. So 13.7 is our answer, but 70.8 still it is not matching with the marking scheme. So it means the equation solver in the case of angles was not providing the direct answer, so exact answer. So can I use calculator? What is the value of pi I have found for 13.7? So shift cosine 4.501 over 13.7, and then close the bracket. Yeah, it is 70.8. So be careful, guys, when you are using equation solver in case of angles. Although it came to us like an acute angle, um, but it wasn't an accurate answer. So it means we need to use this answer. So theta will be, what is the answer we got? It 70.8, which is matching with the marking scheme, one decimal place. That's not the worrisome thing, guys. We found the answer by using equation solver, because a trigonometric equation has infinitely many answers, but you need to find an answer which should be within the given range, yani acute angle. And you keep on changing your guesses until or unless you get your answers within the given yani acute angle range. So we preferred that equation was pretty simple. We can easily calculate manually the value of theta is equal to 70.8, and from the equation solver I can show it to you. We can also get 70.8. Look, what was the pi I was having? 13.7 times cosine of x, close the bracket, alpha equal 4.501. Okay, shift solve. Look at that. This range is 89.1 something. I need to give an acute angle guess. Suppose I give 20 degrees. Okay, so let me try to put equal sign. Look, 70.8 came to us. So it's possible to get the answer from the equation solver as well, but you need to play a sensible game. You need to know or that where your answer is there, or expected answer is there. So you put your initial guess closer to the accurate answer which you are looking for. Question number 9, guys. If you can see, we have three forces and the system in equilibrium, and the system is in equilibrium. He said, like, can you find the angles? I need these two angles. I think when all the three forces given acting on the body here at point O, and the system is in equilibrium, we can use Lamy's rule. Lamy's rule is basically a sine rule. How? This is alpha, and the opposite force to alpha is 8 Newton. How do I write it? I'll write sine of alpha over 8. Come on, this is 90 degrees. Opposite to 90 degree, which force is there? 10. So I'm writing sine of 90 degrees over 10, and then I will solve this equation for alpha, right? Same thing, I want to get beta. So opposite to beta we have 6 Newton force. So I'm gonna write sine of beta over 6 is equals to sine of 90 degrees over 10. So from here I can easily get beta. So shift sine 6 times sine of 90 over 10. This will give you beta. And here shift sine 8 times sine of 90 over 10 will give you the answer. So let's use our equation solver. Sine of x, close the bracket, over 8 equal sign, fraction, sine 90, close the bracket, over 10, and then shift solve. Look, my answer, my alpha is obtuse angle. Look at that. So I shouldn't give a sensible guess here as an acute angle. So I need to give my answer 150, for example. Look, I got 126.8, and this is the sensible answer. Otherwise, the calculator will give you an acute answer. So be careful about using this equation solver. However, if a student says, no, I want to use manual way, so I'm going to show it to you. Shift sign, fraction, 8 times sine 90 over 10, and then close the bracket. Now I got 53.13. Now it is not 53.13, it is obviously an obtuse angle. So in order to make obtuse angle from acute answer, so let me write it first, 53.13. So in the exam you get 53.13, but this is not my alpha. My alpha should be 180 minus 53.13. This is the thing which I am teaching you, how to get obtuse angle from an acute angle. So 180 minus answer. Remember, we already got this answer from the equation solver, 126.9. And to get beta, no need to use this formula. Just from 360, I will subtract the sum of 90 and 126.9. So I'm going to write 360 minus 90 plus my answer. And I got 143.1. Okay, guys, so the two angles, the unknown angles, we have found by using Lemmy's rule. But Lemmy's rule can be applied only when you have system of three forces acting on a body, and the condition is the body has to be in equilibrium. If the body is in equilibrium, you can use Lemmy's rule. You must have three forces given, and then you can use the sine rule, which is basically a sine rule, to find the unknown angles. Clear? Let's go to the question number 10. In question number 10, we have three forces. Then definitely we'll say, is the system in an equilibrium? Yes, the system is in equilibrium. So, Mr. We should use the Lemmy's rule. No, I don't prefer to use Lemmy's rule here, because the guy has shown you x-axis, the dotted line. Resolving forces is much better option here, because it would be so difficult for you to find this angle, to find this angle, to find this angle. No, Lemmy's rule is not helpful. Lemmy's rule is helpful only when he will give you the all the three forces. If he gives you all the three forces, or he gives you all the three angles. But in this case, he gave us all the he gave two forces and the third force is not given. Okay, did he give us all the angles between the forces? No, all the angles between the forces are not given. So it means that the Lemmy's rule will not be helpful for you. So go with the last resort, which is resolving the forces into components. So I'm gonna resolve this force, which is 2 cosine of theta. This is 3 cosine of 60 degrees. No need to take p newtons, because p newton is acting vertically downwards. Since the system is in equilibrium, so this force must be equals to this force. So I think this will be easier for us. So 3 cosine of 60. So cosine of theta is equals to 3 cosine of 60 divided by 2. And then theta is equals to shift cosine 3 cosine of 60 divided by 2. But I'll use the equation solver. Keep it in your mind, your theta is acute. Shift, 2 cosine x, close the bracket, equals sine 3 cosine 60, close the bracket, shift solve, and I'm gonna get my answer 41.4. Yes, it looks 41.4 because it is an acute angle. So theta is 41.4. Now come to the vertical components, because I want to get p newton also. So this is the y component, this is the y component. So this should be 3 sine of 60, and this is 2 sine of theta. And this force is p newtons. Two forces upward, one force is downward. So I'm going to write p is equals to 3 sine 60 plus 2 sine theta. The value of theta which I have found it, I need to plug it here. But this is 1 dp, I need to put it here 2 dp's. Let me use the answer from the calculator, which is 41.41. So 3 sine 60 plus 2 sine, come on, what is that? 41.41. 41.41. Yeah, close the bracket and get the answer 2.82. So P is equals to 2.82 newtons. Let us verify our answers from the marking scheme. Question number 10, we did it. 9, we have already found it. Khalas. 10 is 3.92 and 41.4. Let me check, did we get the same answer? Guys, the value of theta was the 41.4. Let me substitute my answer. So 3 sine of 60, close the bracket, plus 2 sine of 41.41, close the bracket, 3.92. That's why I'm verifying my answers. 3.92. So guys, double check your answers in the final exam. You won't do any mistake or writing the wrong equation, because I wrote here 3 sine 60, but in the calculator I was writing 3 cosine 60. So be careful about that. Question number 11 now. Question number 11, he gave you 3 forces. And I think the best way is to resolve the forces. He said that find the fourth force. Wow, beautiful question. He said, like, find the fourth force or a single force which makes the system in equilibrium. You know what the idea come to my mind? I need to find the resultant of these 3 forces, which is not hard for me. How? Let me show you. First of all, 18 Newton is already acting along the x-axis. No need to resolve it. 12 Newtons, since the angle is not given with horizontal, it is given with vertical. No worries. This is the vertical component and this is the horizontal component. So since 60 degrees given and the side which is opposite to it, so this should be with the sine. So 12 sine of 60 degrees, and this thing should be 12 cosine of 60 degrees. Done. Next, he gave you, this is the vertical component and this is the horizontal component. So in front of 30, that has to be with sine. So I'm gonna write here 8 sine 30, and this is what? 8 cosine of 30 degrees. So there are 2 forces upward. Let's try to calculate the x net. X net is based on this plus this. So 12 sine 60 plus 18 minus this, not this, sorry, this, minus sine 8 sine of 30 degrees. Calculate this answer from a calculator. Twelve sine of 60 plus 18, close the bracket, minus 8 sine 30. Okay, and get your answer. 24.39. 24.39, which is a positive answer. Now let's try to get the y net. The y net is two forces upward. Yeah, just two forces upward. So 8 cosine of 30 degree. I'm going to write the equations very carefully. I don't want to do any mistake now. So 12 cosine of 60 degrees. Let's try to get this answer from a calculator. 8 cosine 30, close the bracket, plus 12 cosine 60, close the bracket, and get your answer. 12.93. 12.93. Now we are ready to find resultant. Both x and y's are positive. It means x net is right, y net is up. So my resultant direction will be here. My resultant will be somewhere here. I need to know this angle first. Let me try to get the magnitude. Square root 24.39 squared plus 12.93 squared, and I got my answer 27.6. So 27.6 Newton force is acting. Let me try to get my alpha. Alpha is equal to shift tan. This is how much? 12.93, and this is 24.39. So tan of inverse tan is 12.93 over 24.39. Let me write in the calculator. Shift tan 12.93 over 24.39. Close the bracket, and it gives you 27.9. So it gives you 27.9. So 27.9 means my resultant will be somewhere here. This is my resultant, which is 27 point, not 27.9, 27.6 Newton, making an angle here 27.9 degrees. Wow. It means I can remove this force, this force, this force. I will get a single force which is acting in this direction. A single force. If I remove all these three forces, I will see this body or the particle is moving in this direction with resultant 27.6. But I want to make the system in equilibrium, so it means I need to apply the equal force on the opposite side, right? So when I apply the equal force on the opposite side, this will make the resultant, yani magnitude will be the same, 27.6 newtons, but the direction will be opposite to 27.6. How can I find this angle? I can find this angle because the total angle is 180. So 180 minus 27.9 degrees. Okay, I can write find this angle, or in the exam I can mention it here that a 27.6 newtons force is needed to be applied in the opposite direction of the resultant of three forces which makes 27.9 degree with 18 newtons. You understand my point? That this resultant has to be in the opposite direction of what? Opposite of the resultant of the three forces, and that resultant is making 27.9 degrees. If you don't want to write this thing, then you need to get this angle, which is 180 minus 27.9. Let me show you. 180 minus 27.9. So you will say that 152, the resultant should make 152.1 degree clockwise with 18 Newton. Then the system will be in equilibrium. This is up to you guys to mention the thing which is required according to the question. Last question, number 12. Question number 12, guys, this again, the system is in equilibrium. We need to resolve it. This is our x component, 32 cosine of 20 degree for 32, and this is the y component, 32 y component. I will show later. Now this one is, no, I can't show it because the angle is made with the vertical. So this is 17 sine of 55, and this is p cosine of theta. So two forces to the left, one force to the right. We need to put them equal to each other. So p cosine theta plus 17 sine of 55 should be equals to 32 cosine of 20. Send it to the other side. So p cosine of theta is equal to 32 cosine of 20 minus 17 sine of 55. Let me try to get this answer. 32 cosine of 20, close the bracket, minus 17 sine of 55, close the bracket, and get the answer 16.14. Next, I need to get my y components. This is the y component, this is the y component, and one forces, and also we have, this is the y. There are two forces. So this is 17 cosine of 55. This is p sine of theta. This is 32 sine of 20 degrees. Now let me write my upward forces are 40 plus 17. These two forces are upward. 17 cosine of 55 is equals to p sine of theta plus 32 sine of 20 degrees. Send it to the left. Try to make p sine of theta as a subject. So I'm gonna calculate this answer from a calculator. 40 plus 17 cosine of 55, and then minus 32 sine of 20. Close the bracket and get your answer. 38.81. 38.81. I got p sine theta, I got p cosine theta. You remember I told you p is always equal to what? P cosine of theta and p sine of theta, and this angle is theta. So p is equals to what? 16.14 squared, 38.81 squared. Take the square root. 16.14 squared plus 38.81 squared, and get your answer 42.0. 42.0. And from here I can also get theta, or substitute the value of p over there. So 42.0 sine of, I'm substituting this value here, sine of theta is equal to 38.81 So sine of theta 38.81 over 42.0 and shift sign. I'm gonna use equation solver. 42.0 times sine of x, close the bracket, equal sign, and 38.81, and then shift solve. Your guess is acute, looks sensible. 67.5. So theta is 67.5. 67.5, and the value of p is 42.0. But again, I want to verify my answer from the marking scheme. Question number 11, we have already found it. And yes, 67.4 and 42.0. So guys, here you have seen that I am done with the solutions. If there will be any further inquiry, you may ask me later on. Thank you guys. Assalamu alaikum wa rahmatullahi wa barakatuh.